We're going to start up today just with some popcorn type questions that could be worth just a few points on your exam. So if you are even barely breathing, we should still be good for something like this. If I ask you to evaluate log of 1,000, what's understood to be the base for just log? It's understood to be base of 10. And we can say that the log of 1,000 is what? What is it? It's 3. You count the number of zeros because if it's a base 10, you have 10 to the third here, which is why you have 1 followed by 3 zeros. Just like if I say, what is log of 1 over 100? What would you say that answer is? Right, so again, we're still dealing with the common log, which is log base 10. If I didn't have the 1 here and I said, what is log of 100, you would say 2. But since this is in the denominator, we would say this equals negative 2. Some other quick ones for those of you who are just barely paying attention here. If I say, what's log base 35 of 1, what would you say? Remember, the log, the answer to the log is the power. What power of 35 gives you 1? 0. Right? What if I say log base 903 of 903? What would you get? What power of 903 gives you itself? 1. That power is 1. If I go off the rails on a crazy train, I do log base 5 of the 9th root of 25. We can make this really easy if we've been paying attention. There's a common base here of 5, which is a good thing. But suppose I didn't have this root. Suppose I just had this, and I had log base 5 of 25. What would you say is the answer? What's the power of 5 that gives you 25? You would say the power of 2. But how do I account for this index of 9 in terms of powers? It becomes the denominator of your power, so this becomes 2 over 9. Remember, if you ever get stuck on any of these problems, you can always rewrite this to say 5 to some power is equal to the 9th root of 25. And inside here, we can rewrite 25 as 5 squared inside the 9th root. And we have seen many times in the past how we rewrite this to say 5. It's still 5 squared. The index becomes your denominator, so 5 to the 2 over 9th. And remember, the big thing about solving these exponential equations is that if the bases are the same, you can then equate their powers. So x, the answer is going to be 2 over 9. We were working with change of base last time, so these guys were super fun. If I do log base 32 of 4, you don't need to go to the calculator. That is not necessary here, and this is a question that would be on the non-calculator portion of the exam. Is there a common base between 32 and 4? What's the common base? 2. You've got 2 ways of doing this. You could do this exponential equation and get the common base, or you can rewrite this to say that's log base 2 of 4 over log base 2 of 32. Remember, the base of your logarithm goes in the bottom whenever you do the change of base theorem. By recognizing that these guys have a common base of 2, the next part should be super easy. Because if you were going to solve the exponential equation, you would still have to know the answers to these guys. Remember, the answer to the log is the base. Is the power. So what is the power of 2 that gives you 4? And what's the power of 2 that gives you 32?
4.
Try again. That would be 2 to the 5th power. So all of this is 2 over 5. We can do a similar question. If I say, what is log base 27 of 81? What is the common base here between 27 and 81? The common base is 3. So let's rewrite this using that change of base theorem. So that's log base 3 of 81 in the numerator over log base 3 of 27 in the denominator. If you know your powers, it's pretty simple to work through these problems. What's the power of 3 that gives you 81? 4, and the power of 3 that gives you 27? 3. And there we go.